Okay, so we're going to look at some graphs and we're going to determine their domain and their range. We're also going to answer some questions about them. All right, so let's think about this parabola right here. And I want you to realize that this is really going forever on the left, it's going up forever, and it's going up forever on the right. And really, it's going forever outward just very, very slowly, and forever outward in this direction just very, very slowly. So when we think about the domain, I want you to think about taking each thing that is on this graph and just going each point, for example, that point right there, and going straight down to the x-axis. So every single point squishes onto the x-axis. You can think of a trash compactor just pushing this thing all the way down to the x-axis, or the bottom half all the way up to the x-axis. And when it crushes onto the x-axis, nothing crinkles. It just goes straight up or straight down. So if we think of that, this graph would end up covering this entire x-axis. The domain would be all real numbers. So we would say our domain for this graph, and I'll go down here for it, is going to be negative infinity to positive infinity. And I need a little negative in front of my infinity symbol. All right, the range on the other hand. So let's go back to that graph. The range, if we think of the trash compactor squishing this graph instead toward the y-axis, so our trash compactor is working vertically and it squishes everything onto the y-axis. So for example, this point would go here, this point would go here, this point would go here, and so on as it squishes it toward the y-axis. The lowest value would end up being right here at a y value of -4. And then since these are going up forever, the highest value would be infinity. And of course, every point in between -4 and infinity would get covered. So we have to use what we call that interval notation. All right, so our range will start at -4. It will include -4, so we need a square bracket, and it will go to infinity. And remember, infinity always has those open brackets next to it. And we've got to be in order, so smallest to largest. Don't reverse these two. All right, now let's find these other things that I've got listed here for this graph. F of 2, and that's supposed to be a little f, and Word just continuously capitalizes. All right, so this 2 is the x value. So what's in our parentheses when we see functional notation is the x value. So we're looking for a point that has 2 as its x value. So let's go back to our graph. Here's 2, and let's notice if we hover right there on the graph, 2, 0 is that point. Its y value is 0, so the answer this is looking for is 0. He gave us the x value of 2. We're looking for the y value of 0. Now notice our next one says we're looking for the x values such that f of x equals 5. And remember in a previous video we said f of x is the same thing as y. So we're looking for where y is equal to 5. So let's look back at our graph and let's find y values of 5. So here's 5 right here on the y-axis. Let's move over. There's a point right there where, and I'm hoping that it will kind of pop up for me. Maybe if I click on it. Yeah, there we go. I'm a little bit off of 5, but there we go. 3, 5. Notice that x value is 3. Now we also, though, have another one over here, right there, and I'm slightly off. Gotta slide around a little bit on this graph. -3, 5. All right, so our y value is 5 at -3 and at +3. So the answer here is x values of 3 and -3. All right, x-intercepts are the places where our graph touches the x-axis or goes through the x-axis. So let's notice we've got this one here, negative 2, 0, and we do want to list it as a point. And then we have this one here, 2, 0. So our x-intercept, we actually have 2, is negative 2, 0, and positive 2, 0. And we will always have, whoops, I can't type. We will always have a y value of 0 for our x-intercepts because we're on the x-axis, so we're not going up or down on the y-axis. All right, now y-intercepts. The y-intercept is where our graph is crossing the y-axis. So let's notice there's only one place, and that's right here, and that's 0, negative 4. And you'll notice for a y-intercept, the x value will always be 0. All right, so let's take a look at a second example and take it through some very similar questions as we did this one. But first, I want to introduce the vertical line test. If we can draw a vertical line anywhere on a graph and cross the graph twice, it is not the graph of a function. Now, let's notice if we go back to this graph here. Any vertical line I attempt to draw, so if I draw one right here, or if I draw one right here, no matter where I try to draw a vertical line, it only will pass through this graph one time. That means that this is the graph of a function. So this one passes the vertical line test. It is a function. Let's look at a second one. So now let's look at this graph of the circle right here, and we're going to answer some questions about this circle. So I'm going to go back here, and the first question we're going to answer is we're going to find f of 1. Now remember, 1 is the x value. When it's in the parentheses like that in functional notation, that's the x value. So we want to find a point on this graph where the x value is 1. Now here's the x value of 1. Notice the x value is going up by 2. So here's 1, and we trace down. Here is the point where our x value is 1, and that point has a y value of negative 2. So this answer is negative 2. Now let's answer the second question. The x value is such that f of x equals negative 2, so that the y value is negative 2. Well, we already know one of them is 1, but let's look back because there's another one. So we're looking for a y value of negative 2. Here's the y value of negative 2, and here's our x equals 1 that we just got. But if we go across here where there's also a y value of negative 2, is that point right there. And let's notice the x value there is a 5. So we need both x equals 1 and x equals 5 for our two x values, where the y value is equal to negative 2. All right, now let's get our x-intercepts. All right, so we are looking for the points where this crosses the x-axis. Well, we've got that point right there. That is 3, 0. And then y-intercepts. Well, if we look back here, we're looking for it where it crosses the y-axis. Well, it does not cross the y-axis, so it doesn't have a y-intercept. And it's certainly possible to have no x-intercepts and to have no y-intercepts. All right, now let's get the domain of this. Remember, when we talk about domain, we're talking about x values. Let's think of squishing this circle onto the x-axis. And when we do so, for example, this point would go straight up. This point would go straight up. All these points in between would go straight up. This point over here would go straight up. So think of that trash compactor squishing that thing up onto the x-axis. Our leftmost value will be right here at 1, and our rightmost value will be right here at 5. So our domain will go from 1 to 5. And we need our closed brackets to show that those are actual points on the graph. All right, so now let's look at the range. For the range, let's look back at our picture. Let's think of squishing this circle onto the y-axis. So that point would end up over here. That point would end up over here. Everything in between will end up right along there. This point will end up over here. So if we think about it, that circle would get squished between here and here. It will start with the lowest value of -4 and the highest value of 0. So our range is -4 to 0. And again, we'll have those square brackets because those points are actually on the graph. Now, is it a function? Well, let's look back here and notice that if I draw a vertical line right here, it will hit 2 places on that graph when I draw a vertical line. So this is not a function. It fails the vertical line test. So no, it fails the vertical line test. It's not a function. All right, now one last test, and that's a 1-to-1 function. And a 1-to-1 function has no repetition of y values. And we can do a horizontal line test to test if something's 1-to-1. Horizontal, there we go, line test. If we can draw any horizontal line through a graph and touch it twice, it is not 1-to-1. All right, so let's look back at our circle and let's notice that I can draw a horizontal line and it'll hit that graph twice. So this circle is not 1-to-1. In fact, the parabola we looked at in our first example also was not 1-to-1. But if I were to draw a line, this line is 1-to-1. If I do a horizontal line anywhere that I desire, it will always just hit that line one time. So it is 1-to-1.